Hello. Last time we learned about decay diagram like this. This graph explains about the relationship of energy and wave vector at the germanium and silicon and gallium sides. Through this graph, we can know about indirect band gap and direct band gap. Indirect band gap have no pillows because conduction band and hole is the same. There is the same line in the balance band, so there have no pillows, but indirect band gap have delta k amounts of delta k have pillows, so there is we can say this is non-effectively. And then this factor, through this factor, and through this CK diagram, we can gain the fact that is, we can gain the effective mass by the EK diagram. And then we can know about carrier velocity by effective mass. The more smaller effective mass, the fast carrier velocity. So through these things, we can gain the carrier velocity. And then we learn about intrinsic semiconductor. Intrinsic semiconductor is about that does not trace any engineering. And then in this part, we learned about the mass action law. Mass action law is the Ni square equal N0 and P0. This means is carrier concentration in intrinsic semiconductor square is equivalent that electron concentration in the intrinsic concentration and hole concentration in the intrinsic semiconductor. And then we learned about doping. Doping is the material. There is the material. We add the other material, and then we can make many electron or hole. You can say this material is donor or acceptor. Donor is the we can say the fixed charge or ionized charge. This charge is in the group 3 material or group 5 material. The represents of group 3 material is barium, and the represents of group 5 material is phosphorus. If we add the group 3 material, we can make p-type semiconductor, and if we add the group 3 material, group 5 material, we can make a n-type semiconductor. And we learn about the Hall effects. Hall effects is we can distinguish the n-type and p-type semiconductor. And then we run the carrier consideration. As I said before, we can learn, we can know about carrier velocity if we know about how much carrier in there. So we want to how many carrier exist. To know, we have to gain the total carriers concentration. To calculate this carrier concentration, we have to density of states. We have to gain the density of states. So we calculate the DOS in 1 dimension, and 2 dimension, and 3 dimension. In the 1 dimension, DOS is proportional to the root E, and in the 2 dimension, is proportional in the E constant, and then in 3 dimension, the DOS, the density of states is proportional in the 1 over root E. And then we for gain the carrier concentration, we have to know about the probability. So to know this probability, we supply the concept is Fermi direct distribution. Fermi drop distribution is mean about that is probability of carrier exist the probability that is 50%, and then these two elements through these two elements we can gain a carrier concentration. The total carrier concentration is equal DOS, the density of states double, and Fermi-Dirac distribution. And we learn about current density. Current density is equal Qn mu E. Qn is how many charge per unit length, and the mu is mobility, and E is electric field. Mu E is how fast carrier is. So then we learn about degenerate semiconductor. Degenerate semiconductor is lost the intrinsic probability. Uh, as I said before, we can doping the semiconductor, but if we much donate doping the semiconductor, the semiconductor have semiconductor loss the own property. If we so much doping to the semiconductor, the Fermi level is up or down, and we can gain the fact that is if we so much doping to the semiconductor operates like conductoric like operating, and then we learn about the currents. The currents have two types current exist. One is draft current. Draft current is electron uh, is drafting by the outer electric field. So this current depends on three types of elements. Uh, there is the ionized impurity scalar and lattice scaling and surface roughness scaling. Such this factor through this such three elements, the current velocity is slow. So because these things, the, there have there is uh, there is a total time of flights, and then we run, and the other type current is diffusion current. Diffusion current depending on two elements. One is one is uh, one is the carrier concentration and carrier gradient. Uh, Depending on two things, the uh, diffusion current is faster or slowly. We learned about the current, two-type current. So you can say the total current density is n drift current plus p drift current and n diffusion current plus p diffusion current is the total current density. And then diffusion current is Q and D, and diffusion dose. 여기 in here the diffusion current, in the diffusion current there is uh, have a difference coefficient. Different coefficient is mean the how fast the carrier is and how far carrier is. These things is upon depends on the uh, current velocity. Thank you.